on the 5.2, we're going to be dealing with fractions. We will be solving equations that involve fractions. The first slide, though, we're just going to deal with like simplifying some complex fractions. So when we have fractions, we don't like to see like a fraction on the numerator or denominator of a fraction. So we like the fractions just to be like a single thing on the numerator, a single thing on the denominator. Okay, we don't like fractions in both spots. So whenever you have some yucky looking fraction like I have with A, I just focus in on looking at the numerator of the fraction, looking up here, and I just focus in on its denominator. So that had a denominator of 6. And then I look at the bottom half of the fraction, and I focus in on the denominators that are there. So I look at my fractions, the 6, the x squared, the x, and try to find the least common denominator amongst those. So looking at the x squared and the x, what would be the least common denominator with an x squared and an x? It's actually x squared. You have to go with the highest power. Yeah. When you're factoring out, when you're doing GCF, it would be the one with the lower power, which would just be the x. But finding common denominators, it's the higher power. So for my denominator, it would be an x squared. Now from the numerator, it's obvious because it was just a single thing, which is 6. So looking between the numerator and denominator, altogether, it would be a 6x squared when you combine what the numerator denominator would have been and the denominator from the denominator. Okay. So once you've determined what that would be, basically if I multiply both the top of my fraction and the bottom of my fraction by the 6x squared, it would make the extra fractions here go away. And I'm allowed to do that because whatever you do to one side, as long as whatever you do to the numerator of a fraction, you do the same thing to the denominator, it's legitimate. We're allowed to do that. So if I times the top of the equation, the top of the fraction by 6x squared, and then multiply the bottom of the fraction by 6x squared, that's really like multiplying by a 1 because 6x squared over 6x squared is 1. So we're allowed to do it because we did it to both the top and the bottom. So now when I multiply here, this 6 would cancel with the 6 right here. So these 6's cancel. And then this x squared would be times with this x. And what is x times x squared? X to the third is correct. There's an unwritten 1 here. So the rule with exponents says you just add the powers, 2 plus 1. So my whole numerator ends up just becoming an x cubed. And then when I multiply to my denominator, since there was a plus sign right here, I'm going to have to distribute that 6x squared in. So when I multiply 6x squared into this first fraction right here, I can see that my x squared here would cancel with the x squared here. So I'm really just multiplying a 6 to the 3x minus 4. And then I have to distribute the 6x to the 1 over x. Now when I distribute there, this x, that x to the first on the denominator, and this x squared, I can cancel out an x. So this x right here would cancel out one of the x's here, making that an x to the first instead of an x to the second. So to my numerator of 1, I'm really just multiplying a 6x to it. So then I have a plus 6x. Now I do want to simplify that denominator a bit more, so I'm going to distribute the 6 in. So 6 times 3x is 18x. 6 times negative 4 is negative 24. And then I have a plus 6x. So I do have some like terms. I could combine the 18x with the 6x and get 24x minus 24. Now this right here would be my answer. I'll sometimes see students try to cancel like that x cubed with that x that's right here on the denominator and make it an x squared. But I'm not allowed to cancel there because of the minus sign right here. Okay, so if there's an addition or a subtraction sign between terms, you have to cancel all of it or none of it. So I can't touch the x's. So on this next one, if I want to simplify this fraction, it's a little easier than the previous one because I don't have to worry about finding the GCF from the numerator of the fraction because it was already a single thing. So I just look at my denominator, and I'm going to focus in on that 36 and the 18. So what would be the GCF between 36 and 18? Okay, so 6 is a factor. If I said GCF, I didn't mean to say GCF. I want the greatest, like the least common multiple. So I want the smallest number that both 18 and 36 will divide evenly into, 36. So when you're trying to figure out these numbers, it always needs to be the biggest number or bigger. Just like over here when I had the x squared and the x, it was the bigger power. So 18 would be a factor of both of them, but the multiple, least common multiple that they both have in common would be 36. So 36 is going to be the number that I will multiply both my numerator and my denominator by. So this denominator here will be multiplied by 36, and whatever you do to the numerator, you also have, denominator, you also have to do to the numerator. So on the numerator, I just distribute this 36 in. So I end up with 36x minus 5 times 36. So 180. And then on the denominator, I distribute that 36 in. So when I distribute the 36 to this first fraction, I can see that this 36 on the denominator would completely cancel with this 36 that I'm distributing in. So it would just leave me with my numerator of the x minus 5. Okay, so when I multiply here, the 36 divided by the 18 gives me a 2. So those would cancel, become a 2. And then I do the 2 times the 1, which is 2. Or you could just in the calculator go 1 divided by 18 times 36, and it would tell you 2. Okay, now my denominator can simplify a little bit more. So 36x minus 180 over x, and then I could do negative 5 plus 2 and have negative 3. So that right there is my answer. If you wanted to, your numerator, we could have left it in the factored form where I would have 36 and then the parentheses x minus 5. So it doesn't matter if you have it this way or as 36 times x minus 5 for that numerator. If I want to solve an equation and it involves fractions, I want to find the least common denominator. Once I've determined what the least common denominator would be, then if I multiply the entire equation by that least common denominator, all of my individual fractions will go away, and then I can have an equation to solve that will be easier. Now, one thing to mention before I get going is when you come up with your answer, sometimes you might come up with an answer that actually ends up not working. We're not allowed for our final answer to be any number. The variable cannot be any number that would make our denominator equal 0. So looking at this first fraction, that 2y, what number, if I plugged it in for y, would make that denominator 0? 0, yeah. Same with the 5y. If I plugged a 0 for the y, that would be 0. So if I were to work this out and come up with an answer of 0 for y, I can't use that answer. Okay, so you can never let your final answer be something that would make the denominator equal 0. So sometimes it doesn't even come up as that number, but sometimes it does appear as an answer when you work it out. And then you just have to know that you have to exclude that answer. It's not in the domain. So I'm just going to make a little note to myself that y is not going to be allowed to equal 0. That way, if I work it out and come up with an answer of 0, I know to eliminate that as an answer. Okay, so now to figure out what my least common denominator would have been, I just focus in on my denominators. I'm first just going to look at the coefficients, the 2, the 5, and the 10. Between those numbers, what would be the least common multiple? 2 is a factor, but it's actually not a factor of 5. 10. So if I were to list out multiples of 2, 2, 4, 6, 8, 10, multiples of 5, 5, 10, and then 10 would be 10 times 1. So you can see 10 is the smallest one that goes into, that all of them can go into. Okay, so I'm going to have a 10, and then I'm going to look at my variables. With the variables, you use the highest power, and in this case, it would just be y to the first. So with the variables, they don't all have to contain it. You just find whatever variables they have, put that variable with whatever the largest power listed with that variable. So 10y is going to be, would be what my least common denominator is. So what I could do is I could multiply now. Let me erase this. If I were to multiply my entire equation right here, both sides of that equation by that 10y, my fractions are going to go away. So when I multiply 10y right here, 10y gets times to the numerator, but I can divide that denominator. So if I go 10y divided by 2y, my y's right here are going to cancel each other out. And then I have 10 divided by 2, which is what number? Just 5, yep. So 10y divided by 2y is 5. That means I'm going to times this 3 by a 5. 3 times 5 is 15. Now, if that's confusing to do it all in your head in one step, you can if you want. You could go 10y times 3 and make that 30y, and then put it over the 2y. And then you could say, well, I can see that these y's are going to cancel. And then 30 divided by 2 is 15. So you can do it that way also. So when I distribute here, I can go 10y divided by the 5y. So my y's will cancel. 10 divided by the 5 is 2. So I take that 3 and times it by a 2 and get a 6. Or I could have went to 10y times 3. That would give me a 30y, and then it's over 5y. And then I can see that the y's would cancel, and 30 divided by 5 is 6. Okay, so you can, if you want to, go ahead and multiply it to the numerator, and then divide the denominator after. I like to divide the denominator first, and then multiply the result to the numerator, but you can do it either way. Okay, and then over here, this is one sometimes people will overlook. They'll neglect multiplying past the equal sign, but you have to do whatever you do to one side of the equation, you have to do to the other side. So then I could do 10y divided by 10. So the 10s would cancel, so I'm just left with the y. So I times the y to the 7 and get 7y. Or I could have went 10y times 7, which would be 70y, and then divide that by the 10. And then 70 divided by 10 is 7, and then the y stays. Okay, so my new equation now says 15 plus 6 equals 7y. So this new equation is going to be a lot easier to solve because I now can solve it without any fractions. I can just add my like terms. 15 plus 6 is 21 equals 7y. My next step in solving, since that's being multiplied, is I would just divide. So 21 divided by 7 is 3. Now my answer didn't come out as 0, so I'm good with that answer of 3. Now if I wanted to know for sure that I had the right answer, I could go and plug 3 into the original problem. So I would have 3. Now on these calculators, if I went alpha y equals the number 1 numerator denominator, I could just type it in as a fraction. So 3 over 2 times 3 plus alpha y equals 3 over 5 times 3, and then enter. And it tells me my answer is 7/10, and that's what this right here said it should be. So that lets me know for sure I came up with the right answer. On this next problem, again, I don't want to work it out with the fractions, so anytime I have fractions in an equation, my first step is always to get rid of those fractions. So I figure out what the least common denominator would be and multiply by that. So again, focusing in on my denominators. When your denominators contain like a binomial, a trinomial, more than a single term, like this one where it's separated by subtraction, we want to make sure every term is first factored. So looking at the t squared minus 4t, this is not factored. So I want to get that one factored first. So what would be the GCF on this one? Not the 4, just the t. When you do GCF, greatest common factor, you use the one with the smaller variable. If they both have the same variable, you use the smaller power. So both of these, the t squared and the 4t, both contain a t. So my GCF is just t, so I would rewrite that as t and then parentheses. Now if I divided each of these by t squared divided by t is just t. Negative 4 divided by t is negative 4. So that's what this one becomes. So you always have to make sure that denominator is factored. You might have to sometimes do an x factor if there's 3 terms in it, but just make sure it's all in factored format. Once it's in factored format, to identify what your denominator should be, is you now just look at them all, and I can see that here I have a t, and then right here underneath this 3 I have a t. So I'm going to have a t, and then I see that this here I have a t minus 4, I have another t minus 4. So I'll use a t minus 4. So I make sure I use every term, every type of term that's there. So t times t minus 4 is going to be what the greatest common denominator, or the least common denominator would have been. So now I'm going to go and multiply my fraction by this. So when I distribute to here, when I have this in factored form, that denominator is t times t minus 4, I can see that both the t and the t minus 4 would cancel with this t and t minus 4. So since those would cancel out completely, I'm just left with my numerator of the t plus 9. And then here, where it's a minus, I usually, if it's a minus, I'll put that as a plus, and then put the negative right there. So then I'll have plus negative 3, and then when I multiply this t times t minus 4 here, I can see that this t on the denominator would cancel with this t right here. So I'm really just multiplying that negative 3 by the t minus 4. And then when I distribute here, I can see that this t minus 4 would cancel out this t minus 4. So I really only have to multiply the 1 by the t. And 1 times t is t. Now I have an easier equation to work out. I just now need to simplify, combine like terms, isolate the variable. So distributing, so I'll have a t plus 9, and then negative 3 times t is negative 3t. Negative 3 times negative 4 is a positive 12 equals t. So I can combine the 1t and the negative 3t. So 1t minus 3t is negative 2t. The 9 plus the 12 would give me 21 equals t. Now I want to get the t's on the same side of the equation. So I'm just going to choose to add the 2t to both sides of the equation. So then I get 21 equals 1t plus 2t, which is 3t. And then I divide each side of the equation by 3. 21 divided by 3 is 7. Now, one thing I forgot to do is I didn't initially check to see what numbers your answer couldn't be. If I went back up to my original problem, I just, again, make sure I recognize that my final answer can't be any number that would make the denominator be a 0. So from this t minus 4, if t had come out as a positive 4, then I would have had a 4 minus 4, which is 0. So a positive 4 wouldn't have been allowed, which is fine because I didn't get a positive 4, I got a 7. From this fraction right here, where it was just a single t, that one wouldn't have allowed a 0. But I didn't get a 0, so I'm okay. And then this one over here didn't allow the 0 or the 4. 0 and 4 on this one, either of those numbers would have made this first fraction equal 0 on the denominator. Okay, so t equals 7 is an okay answer because it doesn't make my denominator equal 0. Okay, so more complex than the other ones. This one involves trinomials. So when I want to figure out what the least common denominator would have been, I first need to make sure everything is in factored format. So since they're trinomials, that means I'm going to need to do the x factor. And actually nice that this first fraction and the last fraction are the exact same. So once I know what the x factor for the first fraction will be, the second fraction will be the exact same thing. So for the first fraction, I need to come up with two things that multiply to give me 30, that add to give me negative 11. And what would that be? Okay, so negative 5 times a negative 6 does multiply to give a positive 30. Negative 5 plus negative 6 does add to give a negative 11. So then this would become, I'll just rewrite the whole problem, 6 over, my variable was an x, so x minus 5 times x minus 6 equals 2 over, now x minus 6, that's already as reduced as it can go. There is no GCF that you can pull out. So I just leave it as x minus 6. And then 1 over, and then since this was the exact same as the first one, I know it'll be the same factor of x minus 5 times x minus 6. So once I have them all in factored format, I now need to identify what the least common denominator would have been. So you basically use your factors that you see. So I see an x minus 5, x minus 5. So my least common denominator would have an x minus 5. Here I see an x minus 6, x minus 6, x minus 6. So I have to use an x minus 6. And then there are no other factors listed on the denominator that I haven't already accounted for. So I have identified what my least common denominator would be. So if I were to take this whole equation right here and multiply it by the x minus 5 times the x minus 6, all of my denominators should go away. So when I distribute to here, I can see the x minus 5s right here are going to cancel. The x minus 6s are going to cancel. So everything canceled there. The only thing I'm left with is that single 6. So I get 6 equals. Now when I distribute here, I can see that this x minus 6 would cancel out with this x minus 6. So it's only an x minus 5 that I need to multiply by. So I'll do the 2 times the x minus 5. And now when I distribute to this fraction, this x minus 5 would cancel with this x minus 5. This x minus 6 would cancel with this x minus 6. So these right here cancel completely, and I'm just left with my plus 1. So I go from that yucky looking problem to this nicer one to solve. So I'm just going to distribute my 2 in. So I get 6 equals 2x minus 10 plus 1. So 6 equals 2x, and then negative 10 plus 1 is negative 9. And then my next step, I would add 9 to both sides of the equation. So 6 plus 9 is 15, so 15 equals 2x. And then my last step would be to divide by 2. So 15 divided by 2 is 7.5, or you can leave it as 15 halves. Okay, now I do need to make sure that my answer wouldn't make my denominator equal 0, because again, you can't use anything that would make the denominator 0. So looking back at this problem here, 6 over x minus 5 times x minus 6, the number that would make this first parentheses equal 0 would have been a 5. 5 minus 5 would have given me a 0. But I didn't get 5 as an answer, so that's okay. From the second parentheses, x minus 6, 6 is the number that if you replace the x with it, 6 minus 6 would give me a 0. So I'm not allowed to use 6, but that wasn't what my answer was, so I'm okay. And then this one doesn't allow 6, this one doesn't allow 5, that one doesn't allow 6. So since none of the numbers that would make the denominator equal 0 were listed as what I came up with when I solved, that lets me know that the 7.5 is my answer. Okay. But if that answer had come out as, say, 6, and I knew I'm not allowed to use 6, then I would cross it out, and then it would have been no solution.